Yes, welcome to our afternoon session. So this morning, we talked a little bit about the quality assurance and quality control, and then trended into a whole bunch of other discussions. We did also have the discussion on sensor metadata as well. So we were talking about the different vocabularies, things that we would need to help get that standardization and also tie into quality assurance and quality control. So I had originally scheduled a little bit more time to talk about QA/QC, but do people feel as though we sort of got good coverage of it this morning? Is there anything that anybody would like to add or further questions? Yep.
Well, no, let the rest of the room say. I've got a couple of things.
Yep. I think it might be with you then.
So, well, it was just to follow up on a few things. Flagging information. We talked about the vocab. It would be useful for me to know how that flagging is done. How you hold, I guess, a technical question. How you hold that flagging information. You hold it per value, or do you have a flag that occupies a certain sensor for a certain length of time? Those are the.
Yeah, I mean, we were just talking about this at lunch too, as I would say, one, this is all still in development heavily, but currently the flagging on my side for what I've been adding in is more about trying to correct the initial information as soon as I can. So I hold it in a database for a year, so I have access to it, but I'm not connecting it to the data that's being offloaded to the data centers, and whether or not that needs to take place as well. But the data centers often have their own way of flagging, but I am flagging like minute averaged data per variable, whatever I can flag within that in a minute averaged time period. And that minute averaging has more to do with how influx and the architecture of that system, as opposed to why I wanted to do a minute versus the actual like second sensor.
Or whatever the raw
measure.
frequency is.
Right, exactly. But yeah, so, and then, but I'm keeping that so that I can review it and get at things like you mentioned, where can I see that we've set something up incorrectly, and make those changes at that point. But in terms of like setting up, this is data fit for a certain purpose down the line, I'm not doing that.
So we've got the flagging, and then we also did talk about the potential links to configurations or you know, in the broad description of the term as well. So thinking about how to do that. I think in our database, and Tess, I'm not sure if you're online, but I know that we have quality flags associated with certain variables, but we do have them at the record level. That's the way that we're approaching it.
But what do you mean by record level?
So as an database record where we, it would be every, I think it's 10 seconds or a minute. That's when it comes in, and then it's associated with I'm probably thinking of our underway merger file. Tess, are you online? No, I think that she's
online.
She is online?
I mean, she's there. Okay.
Might be asleep on her keyboard. I won't blame her. I'll try and get some clarity on that, but
it's interesting that both of you use it on a time merged, on a time aggregated.
Yeah. Yeah. I think it is time aggregated.
Maybe to answer your question, I know for some colleagues in Austria, what they do is really per record. So that means that for every single measurement value, you have a matching flag.
Yes, that was the original
WSKey system.
That was the original intention of the data backend of our version of RVDAS, was that every single value had an associated flag value, but we hadn't actually got any QA/QC routines into, it was just taking up vast amounts of space
Mhm.
and no benefit. But the interesting thing is whether you add all that information in and have lots of extra storage, when some flagging information goes on for minutes, hours, days, weeks, months, and you end up having a repeating. And I know you can get shot of that through compression and stuff, but it does add lots of storage overhead to what could be a very simple thing, which is a flag started on this center with this parameter from here, this time to this time, which is, you know, it's a fraction of the size, but tells you the same information.
So in that sense, I do have a separate set of metrics that are being rolled up too, so that in theory, as we get larger, I don't need to keep the high level frequency flags, but I have more of a overall view on an hourly basis as well. And so there's they become metrics though, as opposed to like individually flagging
data points, yeah.
data, but the point of my system is more about sensor health as opposed to like the data itself.
Right.
I was wondering actually for what you said about these flags and so. I know that some of my colleagues, as I said, in Austria, were doing the flags. On my side, I was more thinking about data quality level, data products, and saying I have a raw data and then I have different levels of data quality. And with the system I will present it tomorrow, I can regenerate on the fly anything, any quality level from the raw data.
Mhm.
I'm wondering actually, or I'm wondering more and more now, should we go more of a way of flags and storing flags, or should we just generate preset quality level data products?
And so this gets back to that conversation earlier about having that service level and you just try and stay within it versus being able to sort of composite those flags up to an arbitrary, you know, moving level. And so two directions. I would say. So one is strict boundaries and you can bounce in between them, whereas the other one, you know, you build your classification dynamically of sometimes we're level A, sometimes we're level B, as opposed to we're in or out of something that was prescripted.
I would say to my mind, for the data user, actually a few set quality levels are enough.
Yeah.
So I think it's more a matter is, do we prefer to have a flexibility of doing flags?
Mhm.
And then you can generate quality levels out of these flags?
Yeah.
Or do you just go directly for preset quality levels?
Yeah. And sort of say, how much flexibility do you need? I mean, obviously, everybody would like complete flexibility and do whatever you want, but the reality is that then that there are storage demands and cost demands on that as well. So this gets back to that cost versus marginal benefit argument. Who really wants it and how much do they really need it?
But I'm not so sure that so many people would like to have intermediate levels.
Yeah.
I see only the need to have not filtered data if you want to work on filtering procedures, and then for sure you want to have a raw data that you can experiment with it.
Yeah.
For most of your users, actually, I try to refrain in data product. I don't really want to like interpolate over gaps, for example.
Yeah.
So it depends on the application. I prefer to let the application decide what they tolerate and what not.
Mhm.
And even so, people complain that they just want to have data product you can blindly use and done.
Yeah, sort of the good enough approach. It's good enough, you know.
So it's the best you can do. I take the best.
Yeah.
I don't really
And
care
it's-
about the intermediate steps before.
Yeah, and I think that those do tend to be the two camps. You get the hydrographic scale, I need top shelf quality. And then the other one is just give me whatever you got, I don't really care. So it's kind of those two things.
Perhaps we should also make a distinction between the moments, the phases that you flag. I mean, you have data coming from a vessel, data being processed and then submitted to a data center or a group of data centers in a project.
Mhm.
And those are different phases. You can have different flags for each of these phases. For instance, if we are submitting data, CTD data, for instance, to CDataNet, European project. And there we're also using, those are processed data. And by definition, they have all the flag good, all good values, because we do not knowingly submit bad data to collating data center or group. So it doesn't mean that they're all good data. I mean, it can happen that if there is some quality control done, performed by CDataNet, that they come back and say, well, we have our questions with these data, so please have a look at it again. But by definition, we submit good data to CDataNet in this case. So I would say there are fairly different phases. We may have different quality flags.
Yeah.
The data.
Yeah. And I mean, this does tie into the grander theme of provenance, being able to sort of trace where things have come from and what has been done to them. And there's various degrees of resolution of understanding that, but it is this notion of being able to understand the history of your data, either as a collection or as individual pieces.
Yeah, for that particular example, you haven't got a data flag anymore. You have an organizational quality flag or an individual quality flag, because you make an assumption that the data that is submitted is good. But that's not based on the data, that's just based on who's submitting it.
Blanket, it's a blanket assignment, yeah.
Which is similar in some senses to what Beck was saying about SUSE. The quality flag is that SUSE has basically given accreditation to the individual or the organization that's providing the data.
It has a quality level of SUSE.
Yes.
Yes.
Well, as a SUSE provider.
Yes.
But there is a standardization that is going on because of the RDAP underlying the SUS map. So whenever there is a parameter, it has to be mapped to the terms that RDAP is understanding as this is temperature, this is salinity, and then it can be onto the map.
But
But
it could be
it's-
standard, but it could still be rubbish.
Yes, yeah, but so that's on the metadata level. It's not the quality of the individual value.
Yeah. And there are these different hierarchies of, it might be, there is a standardization in terms of there may be some field checking, but the content, it's, I've run into this, as I said myself, where, is that supposed to be 4 degrees? No, it sounds good to me. And they said, no, of course it's not supposed to be 4 degrees. It's hard for the data people to say. Frank.
I think with the granularity of the flags, it also depends like how they package the data in the end for the users. I mean, if they're like data sets of like cruise level, like sensor data, or if it's, packed in a daily data set. And I mean, people who would use those would look, okay, only takes the days that are good, or they only picks the data from a cruise that are flagged good. They don't necessarily want to go onto the data level, like download all the data, and then check if which data, point is good or bad. Although this could change in the future, it depends how the data is served. If they're all the data from the ship, ever collected are being somewhere in a cloud or whatever storage, and then they could filter in the cloud for things, then give me only the data points from all the cruises that are like flag good, then it's a different matter.
That's what I was going to say. It's the notion of quality filtering. And the thing with quality filtering is that you do need, you get back into this larger issue of you do need flags. You do need those flags to be consistent, as in you don't want to, it's almost a vocabulary of sorts, because you want your flags to be consistent with one another in order to aggregate them together. But then you would also need to have a mechanism of filtering that data. How does that get done? Does that get done as a database query? Does that get done? How does that happen? So sorry, that's not really an answer. That's more me thinking out loud. But if you plan on piecing these things together, you need some system of extracting them and having them be consistent in some way, because it's not good to have ragged things with ragged flags. Other thoughts? Oh, yeah, Susanna?
For multi-beam data, for example, we have some quality control values,
Mhm.
called flags, but at the metadata level.
Yep.
The ones we use for the MONET bathymetry. So it's about the frequency of the ecosonder and how old
Mhm.
is the equipment, etc. And this is the metadata for the whole data set. But for the underway, we flag every value and we have every second. And we can all the values after agrees are good values. In fact, we flag some are clearly bad and maybe probably bad. And we are also very conservative
Mhm.
about I don't know for sure if this is good, but I think it's probably good. And we are confident and the scientists is going to use this.
Mhm.
This, as I said, we'll check because maybe this an anomaly that this is information for me that is useful, and I think this is the point of using the flag system.
Yep. And just to take that point and clarify one of my earlier points, you've got your definition of which is good. My definition of good may be not as good as your definition of good. So this is why, you want to have some understanding of what constitutes good and have a consistent understanding of that, so that when we say, yes, we're taking all of the good data, you're not just getting your good data, but you don't want to be including my, oh yeah, it'll be all right data. You want to make sure that you have that consistent level of quality.
How do you do that then?
Well, this is where I do think you need to have probably some standardized levels of what constitutes quality. And so this gets back to that discussion of, for lack of a better term, what are our service levels? What's grade A, what's grade B, and grade C? And it may be, it may be packaging. We may lose some definition within the individual categories, but at least you would gain some definition in terms of we would know what to expect from that particular service line.
But does that solve what Susanna just said? She said they are very conservative.
Mhm.
So to be on the certain side of thing, you may not be that conservative.
Yep.
So your values will have a much bigger range.
And so I would say object.
And they have the same good flag.
No, I think what would end up happening is once you look at the criteria, if we're explicit about it, hers would come out as grade A, mine would come out as grade B. And I think that would be the definition is you would say Susanna's are fine. Jonathan's, you have to be a little bit more suspicious about them, but that's according to objective criteria. Now, how you would define those criteria, that's complicated. I admit it. But that's the sort of discussion that we're talking about in terms of would you identify some sort of level of assurance?
I think the key is really what you said, service level. Because if we try to define quality levels, we're going to argue for the next 10 years and we won't be able to agree on everything.
Yeah.
If we say at least service level, then this is more neutral, and it's going to be much easier to see. This is like range enforcement, if this is statistical filtering or so, and then you can easily agree. And then you can see that for you stop as statistical filtering, maybe you go to manual observation of the data and recalibration of the sensor, but at least it's clear.
And I think that is a good distinction between the service level and the quality level, and you can take a look at what was done. And where you may have some unresolvable tension is you may have some incompatible ways that you've done it, but at least you're explicit about it. Somebody may have done some statistical process and you say, well, that's valid. And you did a very different statistical process, which is equally valid, but they're incompatible. But at least sort of what to expect from what was done.
And at least you know it's the same kind of conceptual level.
Yeah. Yeah. So again, I think that that's probably that's a good distinction to make. Other thoughts on QA/QC? Yes?
Maybe one more thing. It's also for some of the stuff that we said about automatic QA/QC. And here I think the automatic part is very important when this is performed live on the data. And I see back into my background, I'm in charge of the running numerical simulations for the avalanche warning. So this is operational service running on something like 140 stations, but it's only supposed to be 10% of my time. So of course it has to be automated. And for me, I've done it now for more than 15 years. And I was amazed to realize that actually I was always the first one to spot the problems on the stations. And I was the first one to come to the people in charge of the network to say, hey, how do you look at this sensor here, this station, there's something wrong here. Because they're trying just to have a look visually in the station. And if you have a look every morning on 140 station times 7 sensors, you don't see anything.
Yeah.
And so I think that's here really the value is, even if this is not perfect, you're going to miss lots of stuff, but at least you have a first rough estimate. You can already sort out the most obvious problems with the sensors.
Yeah.
And then if you had like slow drift, as you mentioned before, of course, these ones you won't be able to find it.
And those heuristics and tests, you can build them up over time and say, look,
you can improve
this is-
always, based on your experience.
and this is quite common in software development. Sometimes the testing suite can be more valuable than the code itself, where you know what to expect from it. But you say this is what's expected. We can be loose, we can be conservative, we can, throw up yellow flags, just say caution. But yeah, in terms of identifying what that test harness would be, that's a good body of work to think about. Do you have anything else?
Yeah.
That's okay. That's what we're here for.
Some of the things that we've been talking a lot about sensor quality control for particular sensors, but almost all of the time we need to add space and time to those values, and they tend to come from other sensors, not always, but oftentimes.
Often.
And I always fear that I put less effort into those because I just assume that they're working, especially time. And that I can believe that later down the line, that will come to bite me as well. We have many GPS systems on board the ship, but I'm in control of none of them for an oversight in our scientific commissioning, and they're all ship systems. And time is another one. It matters not for a great many things, as long as it's accurate within a second, let's say, for 1 hertz stuff, but loads of things that we can collect at 20, 50 hertz. And lots of the some of the applications that require that level of accuracy need to be able to match across different sensors that have got network latency and potential jitter in the GPS time stamp that's coming in. So that's another element of, they are both metadata elements that go along with, they are the where and the when of the sensor metadata. But they themselves have inaccuracies.
Absolutely, and I'll give a confessional example at this point. I'll say it does have a happy end to this, but I was going through some of our historic ship data going all the way back to the 80s, and I discovered very gradual clock drift, ongoing clock drift between our system time and the satellite time. And so and a lot of what we were presenting as our data was based on the system time. So we were able to go back and correct it based on the satellite time, but we were just lucky that we had an independent check of time that we could go back with, because it's the space-time coordinates. You think you are where you are at a particular time, and that's your measurement. Whereas, because as you said, your GPS can be dependent, but it's not the same as your clock. So you can run into problems. That's not really a solution, but I'm just illustrating your point that you have to, it's good to have some redundancy and not just assume that everything's wonderful with these base positioning systems.
As an aside, it's one of the biggest set of errors that we have with our event logging are humans recording in local time versus UTC.
Oh, yeah.
Being out by a number of hours. It generally, well, actually, sometimes it's very, very difficult to ascertain who's correct when you've got local systems also incorrectly given the time when you're doing historical.
And we can have a drinking session about people who don't put time zones or anything, and you're hoping that it's UTC, but you're never quite sure. So yeah, it's challenging.
Everybody knows that I always do that at the same time.
Yeah, I'm consistent. Why aren't you?
And the last one I had, sorry to keep.
No.
Whether the concept of a when you've got multiple sensors that are giving you the same information, whether others have a concept of a best stream, so a best nav or a best MET for those when you've got the ability to choose one or the other to provide as a because oftentimes if people say, oh well, sea surface temperature, they'd really prefer you not to give them 7 individual ones. They just want the sea surface temperature.
Give me the right one.
Yes, you'd be like, you can make that decision, not me.
Yes.
And I said, no, give me one.
Hmm.
And then you go, well, it's complicated because this one worked for this day and then this one worked for the next day. And we've got that in the flagging. So do people create merged products like that?
Yeah, and some. Yeah, so we mainly keep things apart. We don't create merge products on our end. But yeah, it's sort of the question of how compatible they are, the different environmental configurations. Some things may be more fit for purpose. If you were looking to get sea surface temperature, has it gone through your heated pipe, or is it sort of in situ? I don't, versus you could have an in situ, which was read by eye versus, one that went through the heated pipe, but it's measured by machine. It's complicated. I think for me, it'll probably end up depending on, the individual situation and the individual context. I don't think there's an easy answer. Other thoughts?
We have a sense of primary and secondary for most of our systems, but I feel like it comes about mainly because scientists want to know which one to use more than the data side saying, this is the good one and this is our meh one. And they can change depending on what the situation is. But I mean, with the system too, we could put out a merged product or an average product or something, but we don't do it as like a standard process. And we're not quite at the point, but we do have some flagging and just looking at, how the different systems drift or change or are biased, between each other. But again, I think to the point that was made much earlier, it's like how which one is actually accurate, I think is always up for question.
And I think that there's an implicit and unspoken level of error acceptance. Nobody ever tells you how much error they're willing to accept. And I think that part of it is, you would want it to be explicit, but how do you know how much error it is unless you have other sensors? And this gets into how many sensors do you want to buy? And then you could have them all vote and then on which one is the best one. But I think it sort of comes down to some people are willing to implicitly accept larger amounts of error, and you say, oh, if they're just 0.2 degrees apart, doesn't really matter to me. You can give me either stream. But if one kind of deviates unexpectedly, persistently, and is noticeably inaccurate or imprecise, then they wouldn't accept that, but you would not be able to get somebody to quantify what it is unless you showed it to them.
I do have an interesting example at the moment. We have at least 5 GPS navigational sources. At least. There's almost certainly individual systems that have got their own inbuilt. And we have the concept of primary and secondary. At the moment, our primary, the motion reference units failed. So it is reduced, probably not to scientific purposes reduced, but it's for navigational purposes. Our secondary is a direct mirror. So one of them is a CPAP on a port side. I don't know why I chose the port side, primary, left-handed, who knows? But it is. The starboard side one of the antennas, one of the GPS antennas has fallen off. So there's the secondary. So I've got 3 more. And the question is, if you want a cruise track, what do I use for the cruise track for this period of time where I know that those are primary and my secondary are degraded? Yet I've still got another 2. So that's the kind of a concrete case for a
Love it.
yes, where nobody, to come to your point, cares. They just want it's like, where was the ship? But I know that behind the scenes that this is going on. So,
Yeah,
I can provide them with a cruise track.
And if you were to twist me into coming up with a quantitative answer, I would say that it would probably lie in that configuration information we were talking about earlier, where if somebody cared about the antenna falling off and cared about the reduced, then they would be able to go to the 3rd, 4th, or 5th. But if they didn't care, then they could just stay with it as it is. So I think part of that information is in that configuration sort of limit. And I think 99% or 95% of the time, people won't care. So they'll just take the first and not worry about any of that information. They'll say good enough. But it's that example where people do care about that final precision, then they would go into that next level of detail in order to pick it out. That would be my hard quantitative solution for it, but I don't know.
I think your point really is having primary or preferential sensor also. This is a discussion we had also for us. For exactly the same reason for me, from my point of view, I have 140 stations. You have like three duplicated sensors on one station. I have no clue which one I should pick. And I want to have somebody who knows the station who decides for me which one I should pick. And then I think in most of the case, and at least especially with modeling, it's actually quite robust. If you just swap for another sensor, it is not really the same kind of sensor, not the same height or something, for a few days or so, even a few weeks, most of the time you just don't care. It's still going to work. If you have a sensor, even where I was talking about solar heating, sensor is 5 degrees too warm for a few hours, most of the time you don't care.
Yeah.
Then I think it's more a problem if you are people looking like into climatology, and so maybe when they really want to go into the details, you give them the raw data with all the explanation what happened, and then they can decide. But for most of the users, I would say you can really do a best effort kind of merge product, and it's enough.
Yeah, it's that
But
level
you
of,
need to be clear to say this is a merge product, and we have one that we publish. We say this is our optimal data set.
Yeah.
And this is for modeling. This is complete complete made of data set. It's a hybrid between different stations, and so we just fill the gap with different other strategies. But at least for most of the applications, you don't care, it will work properly, and you don't have to worry about data.
yeah. Frank, were you there?
Yeah, very similar to that. I think it's good for navigation. Have like, okay, your best navigation, like, like one GPS for halfway, and then an antenna broke off, and you supply some other data stream in from the other GPS. And at the same time, you have all the raw, you probably record all the 5 individual GPS data streams. So if somebody really needs to go back, they can go back to the other level, I think.
And then you store that information and you just ask for more disk space and it'll chili are. All right, any other points on that? I think that was a pretty good discussion. Certainly we're able to pull a lot of good points about that. So unless anybody has anything to add, we'll probably transition into the next area that we were talking about, which are the visualization tools. So we have all of this, well-collected data. It's highly interoperable, but as part of quality assurance and quality checking, as part of processing, as part of getting information out of it, we have tools that we can use for looking at things, for pulling out information and displaying it in graphical form for review. Might go into reports, might be for investigation. As an example, you heard earlier from OpenRVDAS and OpenVDM about Grafana. So within the AADC, I do know that our data officers do use Grafana to take a look at time series and pull out different patterns that way. There is also some tooling, as we saw from OpenRVDAS, but yeah, you can certainly get a lot of value out of Grafana. We do also, as I said, we try and put our space-time information into GeoServer, and through GeoServer, it becomes available as OGC services, so it can be brought into GIS. It can be displayed in web applications, things like that. So those are some of the things that we're using to visualize. What sorts of things do other people in the room use? Do people do show of hands? So does anybody do graphic investigation of data sets? Yep. So I'll go around the room. Alice, I'm gonna pick on you. So which graphical tools do you use for investigating your data sets, your visualization tools?
So on the ship, we do have Grafana as well.
Yep.
Then I think it depends on the data you are looking at, because, for example, the multi-beams, that would be directly on our
Yep.
sea information system, and then we would maybe process them. Yeah, then I think it's most of them, and then afterwards, that would be more like specific Python tools that we have developed that would be used to just flag things.
So are you working with, are those tools based on using NumPy and SciPy and Plotly?
Yeah.
Okay, so that's some good tooling to think about. So at least we have some commonality between using Grafana and Python-based tools. Others? I think you had your hand up as well.
Yeah, we have one in-browser data visualization for time series. For me, the problem, I was kind of thinking about Grafana, and maybe you can answer my question.
Yep.
Is it suitable to use Grafana for long time series? So that means many data points. Because for me, the problem with lots of tools is when you have on the screen, you want to draw something like 25 years of 10 minutes data, or worst case, I have even like 5 or 7 years of 100 Hertz data. Lots of the tools really struggle.
So
You have lots of points that come exactly to the same pixel and so, and I don't know if Grafana is able to handle this.
Yes.
No, it's not at that level. You'd have to subsample it. It won't show, it has a limit to the amount of points it will show on the screen at any given time.
But what it does do, though, by default, is it auto aggregates. It depends what your data source is. Grafana will work on dozens and dozens of different data sources, and they all have slightly different characteristics. But if you're looking at a database backend, and I'm assuming Influx is similar, we use Postgres. It's issuing queries, and as you zoom out, as your time frame becomes different, it will aggregate on the fly differently. But at that point, it comes down to how well your backend can deal with real-time aggregation, depending on what your backend is. So that depends on whether it's SQL based or how well configured it is, but it will work back If I take 20 hertz data, it will work back, just Grafana on its own doing live stuff, it can work back to hours and days on 20 hertz data. Once you go beyond that, because it isn't the number of points, because it'll keep the number of points correct for the scope that you're looking at. But then you get into how quick the real-time aggregation can happen on your back end.
I disagree with you. I think that there's the actual in-browser visualization ability to plot points. And Grafana's front end has a limit to the actual like number of points it can display. So as long as you're averaging, like it doesn't matter your time series back end and what it's pulling. It would matter if you had high frequency data, it could be a small amount of time, but you have too many points to physically for the browser to use a GL system to actually visualize the data. You're correct in that it's, you know, the back end and that piece. So I think it just depends what your question is. If it's the actual visualization, if you want to be able to visualize individual points at a very, very high scale, then usually you have to use something that's using a GL system for the browser visualization, and Grafana specifically has a limit to that, is my understanding.
So it might be interesting to clarify this as a point. We'll sort of set it aside, but we'll try and answer this as a technical question. I think it sort of comes down to, could Grafana as a tool auto scale itself, or would there have to be some sort of manual intervention in terms of scaling the visualization appropriately? And you know, where that would happen, if it would happen exclusively in the back end, or if like for the analogy that I think of is a lot of point visualization tools, they're clever enough to know they don't need to be viewing every single point. They'll pull every 100 and then every 1,000 and then every 10,000 so that it renders quickly, because it knows that, you know, the size of the point is far in excess of any distance that it would have. So let's just take that as a question. We'll try and address that. I might send that as one back to my text and see if we can get it before the end of the week.
Jonathan, this is Webb Pinner. I don't know if you can hear me.
Yeah, Webb, please.
Hey, on this topic, I can echo Kareen's points, but mainly because we endured that battle together. There does come a point where, I mean, if I'm using an ultra wide screen, that's 3,400 pixels. You're going to lose some fidelity in the data visualization just based on the fact there's not enough pixels to show points at some point. But a technique that when I've dealt with those really large data sets, if I'm actually trying to extract information from that data, a lot of times, like one of the common examples that I come up is from a meteorological point, they might be looking for wind gusts and wind lulls. From if you're deploying an ROV or a sensor and you're trying to verify you're not overtaxing your cable, you're looking for spikes. Binning data on an average or a mean or a median, those types of mathematical functions are going to cover up that information. And so it really does depend when it comes to a visualization, you really have to, there's not a one size fits all. You really need to be thinking, it's like, okay, what am I really trying to get out of this? Am I trying to get a trend, or am I trying to identify specific events that have happened in the data? And that really changes the type of query you're going to do on the data. And depending on what you're going to do, there are a lot of opportunities for optimization. Like spike detection is quite easy. You can either look for a min max, or you can do a derivation on the data set over time, you know, basically looking for velocity changes. And that's a very quick way to identify, even among a large data set, those events that you're looking for. So we'll just kind of throw out there that yeah, I mean, unless we develop, and I'm looking forward to this, the 3 million pixel wide monitor, I think that'd be outstanding. But I do think, especially when you're looking at these long-term data sets, I think you do have to have kind of a game plan of, okay, it's physically impossible to display 100 hertz over 10 years. So what do I need to do to the data to reduce the point size without hiding the information I'm trying to extract? So that's kind of when I approach these types of problems, that's kind of the first thing that comes to mind is I know the monitor is only so big. I know the piece of paper is only so big. How can I filter the signal from the noise and get to the root of what I'm trying to extract by visualizing the data?
And another thing I know about from back in my sort of more analytic days is that there's an implicit characteristic scale. In this case, it's sort of the visual scale. It's possible to calculate that characteristic scale, but it's a little bit numerically expensive. So it's not something that you can do just by zooming in and zooming out, but it's that characteristic scale which will be determining sort of your you will have the average, but what your min and max are and your distance between them. In this case, your characteristic scale is probably the distance between your pixels. But as you said, it depends on what you're after. You don't want to, you'll be smoothing out that variability with the average, but in some cases you'll be interested in the minimum and the maximum and all of those. This comes into how do you want to roll up your information? How do you want to represent it using statistics, trends, all the rest of it?
Exactly. And that's actually a trick that we used on OpenVDM on Falcor Classic was when we first implemented it. Is with meteorological. The scientists were very interested in lulls and gusts. And so to counteract, to satisfy that requirement, when we went to visualize the meteorological data, we just generated essentially not artificial, we generated derived data sets that we added just to the visualization, not to the raw data, that actually was still binning just like the average was binning, but it was pulling mins and max, and we were visualizing the mins and the max over the mean, and that kind of satisfied the requirement. And other tools, we've talked about tools, other tools that I've used,
please do.
and Tess and Peter turned me onto this is Chart.js, JavaScript library for visualization, Cartopy, which is anybody who's familiar with like GMT, that's kind of like a Python derivative of GMT. There's an official Python wrapper for GMT. Those who are familiar with GMT, that's generic mapping tools out of, I think it's the University of Hawaii. And that's a kind of a Unix style scripting framework for building complex GIS products. It's capable of doing, draping imagery, bathymetry, you can do all kinds of crazy stuff from a command line and through scripts using GMT, and Cartopy is kind of falling in the same category. And then another tool that I mentioned yesterday was Report Lab, which is kind of like a Python equivalent to LaTeX for as like a typesetting engine. So it makes it it enables us to like script very well formatted complex reports programmatically. So we use that on Falcor and on OceanX and a couple other systems to do automated post dive reportings from their vehicles that have complex statistics, visualizations, dive plots, sensor plots, etc. And it's all done automatically. It generates a beautifully formatted PDF report that scientists just like a lot. So that's it.
No, that's great. And this also reminds me, it's not a visualization tool per se, but you're certainly starting to see greater uptake of notebooks, and then you can embed things like your Python code in them as sort of a nice bridge. It's got good flexibility and can do the visualizations, but allows for a little bit of customization, and people don't have to write all of the code from scratch. They can just use it as a custom tool. So notebooks provide some flexibility in that space as well. Other contributions, things that people use for their data visualization? Yeah.
I work with Susanna and all the team in the marine technology unit. We have several web services all created to serve the data in also both in real time and also history. And then we use also like GeoServer with Postgres to serve data in real time, and also to query the cruises and this that we use them in a GeoPortal that we have. And those web services are used also in a real-time visualization application that we have now developed there also. We call it Fleet. And sorry, I have some notes here. What we also have is a quality control panel own created where we used the CDataNet flags to do the quality control. And then we are able to migrate to export this data to ODB files. And then we have also a some velocity profiles viewer where everything is merged with the map, so we can see the position of the some velocity profiles, and you can check the profile and then export it as you want. And also the quality control panel, something that we like of it is that it's merged also with the map, so you can query the time series data and you can see it where it's in the map.
No, that's great. Thank you. You also just reminded me of something from our part as where, well, a lot of our developers work with Node.js and OpenLayers. But one aspect of that is polar projections are often a problem, especially they had to move away from using Leaflet. Well, they had to do some customizations, but now with OpenLayers, they have done some coding backend to work with polar projections. So if anybody's working with Node.js and OpenLayers and needs some thoughts about dealing with polar, let us know. Other visualization tools, scanning the room. Yeah, Masaki. No, you first. I pick on her all the time.
For our institute, we have several databases, but one of them, in particular, Arctic and Antarctic data systems, ADS, handles the visualization tools, both for the CIS data, CIS concentration data, and the other CIS data getting from JAXA and NASA, as well as vessel tracking course in the Arctic and Antarctic also. So you already saw as a.
Yeah. Thank you. Now we'll move on. Okay, we won't let it go.
Yeah, so similarly, a lot of the Python libraries, but also Plotly that you can call either from Python or JavaScript. Data shader is one that's very good for very large data. It doesn't allow you to individually see each point, but it does some binning of it and kind of it's almost like tiling data as opposed to map tiles. And then MapTiler, which is a similar like OpenLayers open source for tiling vector data. And then observable plot is getting more and more easy to use for creating JavaScript-based charts. And in terms of notebooks and things, I wanted to give a shout out for Quarto. If anyone has looked into that, it's becoming a much more full-fledged way to do both PDFs, HTML, and notebooks all from one system. So you can effectively put together like almost like a Jupyter notebook of code and things, and then you can have it, it'll automatically make it into an HTML website as well as a PDF, as well as a Word document or whatever you want. So I've been playing around quite a bit with that for reporting as well.
So I've got a technical question on that. Does that incorporate authentication as well?
For the HTML, like
yeah.
I mean, it's just building out like raw HTML, so it's not posting.
So you have to put it in your own frame, yeah.
Yeah, you'd have to put it. Well, it's building an HTML based website. You'd have to post it to a server somewhere. So it depends if you wanted to just post it publicly on GitHub or if you wanted to post that elsewhere. But there are systems. There's systems that use things like that have that built in. Like RStudio or kind of things. Yeah.
No, I would normally offload this to my devs. I just know that authentication is a big one. So when you're creating a site, you don't just want to be like, here's our site.
Yeah, it depends on what the use case is, but if you want to have a report that you can hand off.
Yeah,
as
yeah.
PDF
I'm
and-
sure that the PDF would be a good addition in even in and of itself. Stephanie, you wanna talk about what Cyro's got going? You've got some good stuff going on.
No, but I don't think I think everyone's already mentioned everything.
Well, at least, could you tell us what you use so that we can get a sense of the convergence?
Yeah, sure. So Grafana, GeoServer, a lot of those same Python tools. So we're using Plotly and what are the other ones? What's already been mentioned, but yeah, I haven't
But it's
thought
good,
of anything that hasn't been mentioned yet.
but it's, as I said, it is good to get a sense that, there is general agreement that Grafana is a good thing. There is a general agreement that we are operating in the Python space. It's not one size fits all. It sounds like Plotly is a winner as well. GeoServer for delivering spatial information. So it's good to know that if we end up, this is a sense of, yes, there's broad community support for these. So if we end up building extensions or code or using it, we can turn to one another and say, hey, have you got that? Again, at least in the Node.js space, if anybody says, oh man, we're running into problems with polar projections, then they can remember, oh yeah, Jonathan talked about that. And you can talk with, I'll send you on to our developers and he'll say, he told you what? Oh. Any other thoughts on visual? Yeah, Frank.
More a question. I mean, when most what I had is like tools to build visualization. So are you using those mostly as for static display of what's going on with the different sensors, or do you have like an intranet web interface where like scientists can go and zoom in and out and browse and click and like, select different data? I mean, just a question.
So I'll answer that. For us, it's a mix. We do have some static, here it is, you're just going to display it. But there are also some interactive things. So when you provide interaction, you want to control the level of interaction that you have. Or if you want even greater ability to play with things, that's when you get into the notebook space. But at least if I'm understanding you correctly, if you want some sort of dynamic inquiry, you do that through sort of the more controlled widgets. Was that the question?
Well,
or
I'm
no?
just wondering how people do. I mean, I know from usually most of those displays are for like this where the ship is, and this is like the sensor the last 24 hours or 12 hours or whatever data. But I mean, in principle, like a scientist, if you want to do more, you have to plug in and get the data, and then whatever you have on software on your computer. I mean, maybe it's an interface, an API that people can use with Jupyter notebooks. That would be good. But I wonder if some people got into, in the intranet. Most of the ships have some intranet where you can basically click on a web page and then you can play with the data.
Yeah, and so that's your notion of an interface. On the ship, you have the widgets, which are your interface. And if you have a website, that's a different sort of interface, usually based around HTML or JavaScript for exposing the different tools. But it's a similar process that they're widgets, they are interfaces that are connected back to the data. One is just sort of more computer client based, and the other one is more web-based. But these days, what you'll tend to find is that people just use a browser on the ship. And so it's those same browser widgets that you would get through the internet that are also being used on the ship in many cases. I know that our Polar technology team, I don't want to speak for them too much, but they have their own data in real time application. And that's based on being in a browser and using particular widgets to be displayed in the browser. So theoretically, you could take those widgets and display them across an HTTP internet access point. Does anybody want to clarify that, or?
So we use Grafana both for.
John,
Oh, sorry, was that Webb?
yeah, please go ahead. But I'll speak it next. Yep.
Okay, we'll go with Alex and then Webb after.
So yeah, we use Grafana for both kind of maintenance type sensor monitoring type information, but and we also provide effectively public displays, but all of those public displays are just dashboards. So people can go to them individually from web browsers wherever they are on the vessel, and they can have whatever flexibility that dashboard allows them to do. Oftentimes that allows them, in most times allows them to browse through the information back in time. And actually, because I have a forever view, they can actually go back far back as dot. And also the ability for the things that automatically update to decide on their refresh frequency of the information that is coming through to the screen to them, which can be up to 1 hertz of real-time information coming in if they want. That does pose some issues because it's been wildly successful. People use it throughout the ship on phones, on tablets, on their computers. And at the moment, it's because it goes through to our back-end production database. We need to do some thinking because that's where all the underway data is being piled in at several hundred messages a second, and it's also being hit by 50 people browsing it. So
especially if there's an event of interest, it'll probably spike as well.
Yeah, yes. So you get more people, and that's crew as well. So crew use it as a tool to, and we've as time's gone on, we've added things that are useful for people. So loads of people use. You'd think it would be really dull. We've got winch data. I mean, everyone has winch data coming in, but we've obviously integrated that with the amount information about how long deployment is going to be. People use that frequently when they're deciding whether to get out of bed or not.
Alex, this will teach you to develop a successful product.
So people look
This
at
be
it
a
and
lesson
go,
to you.
I've got an hour and a half. This should have been up ages ago. Brilliant.
Yeah.
I'm back asleep.
No, you're a victim of your own success, but that's not such a
That's
bad
not me.
thing.
That's Grafana that's done that. I mean,
Webb, I think it's over to you.
Sure. So with and I showed this a little yesterday with OpenVDM because OpenVDM predates Grafana because I knew I wasn't going to try to write that tool. With the plugin architecture in OpenVDM, we actually, if the vessel operator wants to, they can develop visualization plugins that are like inline processors. I talked yesterday about this plugin architecture in OpenVDM. And what OpenVDM can do on its data dashboard is it can actually do a file by, it basically will visualize individual files. And then you can pick the file that you want to look at for whatever you've written plugins for. I worked with Peter and Tess to migrate that from HiCharts, which was there was a licensing issue there, to Chart.js. And I was able to replicate the zoom and pan functionality in that. So as far as like a scientist just wants a quick and dirty visualization of a spike somewhere, the OpenVDM interface and using a browser like Firefox, they can quickly pick the file they want, frame the data set they want. They can even turn off individual time series if it's like a multi-time series data file, and then make a screenshot of that instantly. On the GIS side, I've done plugins where it'll show an entire cruise track, and it'll show the cruise track for every single GPS that we've got wired in. So if one does go haywire, you can just turn off that data set in the visualization and just show the cruise track from your preferred position indicator. We've also done things with GIS where basically I've wired up OpenVDM on Falcor Classic. We wired up OpenVDM where if the mapping department exported a geotiff from a survey, OpenVDM would actually do the tile cutting and actually, I kind of rolled my own tile server. This was before things like TI Tiler and some of the more readily available tile servers. But I did use that, and scientists really liked that because it gave them, without having to fire up the MB proc machine and Keras or whatever they were using for visualization, they could just go to their browser and they could drill down. If they needed higher quality, they could drill all the way down as far as they needed to from their phone, from their tablet, from their browser, see the data. do a screenshot or, Firefox screenshots, drop that into a presentation and they were good to go. So that we got a little mileage out of that. It's definitely not it's by no means a replacement for Grafana, which I think is a game changer in terms of real-time visualization and dynamically being able to pick timescales. But I can totally get behind the whole, depending on how popular it is on the ship, it can crash your backend because of an overwhelming number of requests. And so this kind of the technique that was used in OpenVDM, it's nice because it's computed once and then visualized many. There's no dynamic querying in the database. And to that point, something that might be considered if you are seeing like heavy hitting of your data in Grafana, you might consider running Grafana tasks to actually kind of cache the data sets needed for those historical visualizations. So that way it's less computation on Grafana to bin it every time there's a request. It's pre-binned. It's just a serving of a pre-canned data set as opposed to every single query having to bin, thousands and thousands and thousands of records.
Yeah, maybe useful to have that prefix scaling. And yeah, thanks for reminding us that OpenVDM has its capabilities as well in terms of visualization, and it's good to be able to have those options and you have different horses for different courses.
Yeah. And if you do have take advantage of caching. It's commonly used in the web world. We use it every day, sometimes unknowingly. If a query is submitted again and again and again and again, if there's a way to just cache that, so it's not a computational exercise, it's just a serving exercise, then that can offload a lot off your back end.
Yeah, and what you can also do, you see this in the spatial domain as well with rasters and building pyramids, tiles for display, you trade off in, there is extra storage required, but you trade it off in terms of you get much better compute performance. So often the storage is less expensive, and if you want quick turnaround, then you'll have it. So you've got these spatial data pyramids, but caching binned versions isn't a bad thing. It's a well accepted practice. Other thoughts in terms of visualization tools or things that people are using?
Can I share my screen?
Sure can.
Just to prove a point.
Alex, we're doing.
So this is live data. Never ever do live data downloads. This is a Cambridge-based Grafana installation. I could go to the ship, but that would go terribly wrong. So the graph you're seeing is a minute of speed over ground taken from a NEMA VTG string. So pretty standard stuff. There's obviously a little bit of variation. It's straight from one of our CPath sensors. Yep. So that's 1 Hertz data, as is standard. And the bit underneath is the cruise track for that 1 minute, which is obviously very dull because it's only 1 minute's worth of data. Yeah. That panel can display, I think its width is something like 1440 or something, but that's the standard panel width you get. So the width will stay the same, but I'm now zooming out in time. I'm now at, so it is aggregating behind this Grafana aggregation. Sorry, it is Postgres aggregation behind the sign, but it's done by Grafana in real time. So we're now at we're at 5 hours of data, and instead of no map, you've now just got the middle of the sea because it's somewhere near. So this is going back out. We're still going. There's still 1 second data. There's no. So I do have, to your point, whereby we also create real-time aggregations, continuous aggregates from timescale DB, which is what we use as the time series aspect. But this isn't using that. This is using the raw data. So this is still going back out. That's a month of data. Now it's starting to take a little longer because we're now at 3 months of 1 second data. So a bit longer, so we're now at, So that's where, to my point, that it's the back end now, that's the aggregation of the back end that's taking time. And you still, and actually, while the aggregation of the speed takes time, it's doing exactly the same thing for the map as well. So that's showing you the full cruise track for that period of time, which is now 8 months. It'll keep going. But to your point, to make that quicker, the pre-aggregations would allow it to be almost instant, because I would start with second data, and then when I'd zoomed out, my query would move to minute data. The user would never know, because you wouldn't be able to see it anyway. And then eventually to hour data and day data, and then I can go back years.
We actually did this with our historical underway data going back, 30 years of 10-second positional information behind the scenes. We have, and the way that we did it is as materialized views. So as we get more information, we just recalculate the materialized views, and so we can get the full domain. So anyways, that's just a way of saying I second your point I second the point of you can create these materialized views, which is effectively caching your database data, and you can use that as a way of getting good performance.
So effectively on that top graph now, you've got nearly 2 years of data, but aggregated in real time with a query that looks like down the bottom there.
Yeah.
And that time group alias is a Grafana thing. And that time interval is the interval of what you're seeing in the top graphs of between October 21 and the present day. But that's just built in Grafana. It's not,
And I'm guessing you've indexed your time key.
Yes, because that's part of the timescale DB extension to Postgres. I know this is technical, but it was just, and I don't know whether Influx, what I can't know, because I haven't used Influx and Grafana, is whether Influx provides that, because Grafana, based on a different data source, can do different things.
So my point, and I'm sorry if I came off too harshly, isn't that it can't be used for long term. It's that it can't physically show every single raw data point.
Absolutely not.
That was my point.
But you could never ever see.
I understand, but my point was that the browser cannot render more than, I believe, 1,440 points at a time. Not that you couldn't bin the data to show long-term and zoom out. So I was trying to get at whether the question was whether you wanted to be able to show thousands of individual actual raw data points versus the overall view. So it was a different question. So that's what I was
Like a
answering.
meta statistic, yeah. And I think that kind of ties back to when I was talking about, you need to think about the scale and, the scale of display and pixel width and all of that, and what you want and how much, if you want to show the full variability. Are there other tools that people want to raise? Or what I would then, go ahead.
Is it possible to see the data from different vessels together?
Oh, that's a good question.
And I mean, if you have several vessels, or the position or the real-time data for the different vessels at the same time.
Do you mean, is it possible to, as in if I had another vessel track or another vessel, could I show that?
Yeah.
Yes, you could. Could you see all of our vessels all put together? Well, that's the point of forums like this, to be able to, or SUSE or other people to put that together. But there's the technology would, I could well have, in fact, I could show you 4 different versions of the same thing, because in that drop down, I've got 4 different GPS, but it would be very dull because it would all be exactly the same track.
And this is also implicitly where you get the advantage of the standardized services and vocabularies, because then you know what to expect. You would say, I'll pull the BAS feed, I'll pull the AADC feed, I'll pull the Spanish feed, I'll pull the Italian feed, but I know what to expect. So I don't have to write individualized tools. So what I am going to ask in the time that we, go ahead, Webb.
Sorry, and I apologize. You tell me if I'm talking too much and I'll disappear. I've got some experience with the multi-vessel, but I think more applicable to kind of what the discussion here is multi-institutional multi-vessel, where basically you don't have control over everybody's infrastructure. I did a project for NOAA where we did a real-time display of the EV Nautilus, which is a not-for-profit research vessel, the RV Falkor, Schmidt Ocean, and the NOAA ship Okeanos Explorer. The key to making that project work wasn't consistency as much as it was documentation of how to interact with their data. It didn't matter that whether or not I could use the same API call to extract the data from all the 3 vessels. I just needed a API call or an API call. And this kind of, when we start talking about, at least in my experience, we start talking about interinstitutional data exchangeability, it really comes down to having a well-documented exposed API for every institution. It doesn't have to be the same as the other institution. It just has to be an exposed API. And some of the tools that I'm moving towards, and I already use with CLog, and I'm moving towards with OpenVDM v3, is the Open API standard for documentation. And it basically, using that standard, it doesn't matter how I set up my API calls, but using that standard, it can automatically generate online documentation for all the API calls that are available, for what additional arguments need to be, options can be fed to extract the information that I need. And with that type of interface exposed, either internally among the desired users or publicly, then that enables, without having everybody to agree to a certain standard, that allows interagency interoperability. So I kind of throw that out there of, just having something well documented is just as useful as having everybody use the same thing.
Yeah. One thing that I would add, though, is that then it puts the burden on the developer to take a look at those individual APIs and stitch them together. It can be effective and it can work, but it does mean that the developer then does need to reconcile those individual differences.
Yes, but in my experience, that is a far lighter lift than getting agencies to buy into a common product. If it takes me an extra 2 hours to figure out the differences between institution A and institution B, that's a far lighter lift than getting an entire institution to move from solution A to solution B.
Fair enough. What I was going to get into is, first, does anybody else have any other sort of tools or visualization aspects that they want to raise? Okay, so what I would then do, we've talked about the tools that we use and the tools that we think are effective, but does anyone have thoughts on tools that they think they need, or what would be useful to have that they don't? So, all right, do people essentially have all of the charts that they need, or are there no issues in sort of bringing things together? Yeah.
For visualization, there's something that I'm dreaming of because I would need it. It would make it much easier. It would be not only to see, like here, to have one graph for whichever variable or multiple parameters on the same graph, but I have in the same way with the same time scale, maybe just below or something, a timeline of metadata events.
Mm-hmm.
The goal would be that you could see at the same time as you look at your data, you have like a surface temperature and see, oh, here I see a small bump that happens, and you have to like, oh, here there's something done on the sensor.
Yep.
And I think that would be very, very valuable, but it's really something you have to start from the beginning. It's how do we pack the data together in the same, ideally like NetCDF file or something. We'll have a stream of data and a stream of metadata, because it might be I think it makes sense to have different timelines for the two.
Yeah, so metadata time.
And then how do we plot the two together, and how do we process that the two can really be stick together from beginning all the way to the user? As a user, I can really look at both at the same time.
And what might relate to that is if you have a metadata timeline and if you have a data timeline, possibly linked by a good date timestamp, if you ended up having a configuration change that was represented in the metadata, if all of a sudden you see a change in the data that resulted from the configuration change, it might be easy to reconcile that. So that's just a thought.
Just to stick on Grafana, Grafana does have, and I don't know whether I haven't used it, but I don't know whether other people have. It's got an annotations which is specifically around that kind of. Its whole purpose is creating annotations, time-based annotations. When someone's looking at a graph, going, "Oh, something's different there," you put the annotation on, but that's not really what we need, because we've all got our own built-in event logging systems. What we need is an ability to bring our event logging information in effectively.
That's what I was about to say, is
annotations.
sort of an adapter from the event log to a Grafana annotation.
But that's only for that particular.
So I would say not necessarily, or not only to Grafana, but also in between, to be able to have like a composite file that the user could go to a web portal, get the file, and get automatically in one go just the data with the metadata, and to be able afterwards also to see it in Grafana in whichever system.
Yeah, and I'm just sort of thinking of the ISO standard. They don't tend to think in terms of a time series of metadata. If it were a time series, they would be doing that as different metadata files. So I don't have the answer. I'm just sort of thinking out loud that at least for ISO, they don't think in terms of serial time.
Tess and I actually, interestingly enough, Tess and I actually had a private conversation yesterday during lunch about this exact topic. And we actually talked about, she was asking more about, is C-Log as an event logging engine, is that a potential solution? And it can be, because that's just a generic event logging engine, but you could have just a metadata type event, and at the end of it, you could get a machine readable record of just the metadata related events exported to file. And then that could travel with the data set, where you can see at the start, it's like, okay, at the start, we were using this sensor with this serial number, this sensor with this serial number, this sensor with this serial number. At X time, this sensor was swapped for this other sensor. And that's kind of like your time series. And then there's a lot of other events that event log systems are capturing, but for the sake of minimizing the number of interfaces that the technicians need to use, they could use the same event logging engine to acknowledge that, hey, this sensor was swapped. And we all know how it goes. In the heat of battle, it's like, yes, that sensor was swapped 2 hours ago. If the event logging system can support inserting an event at any time, then it does allow the event log to remain to be a real-time system, but still remain accurate for events that happened in the past and are now being retroactively applied. And then if the event logging system has a back end, an API, then it can be an automated task to export the subset of that overarching event log record that was captured during a cruise to build that metadata record that tracks instrument changes over time for the given cruise, or even for a smaller time scale. If it's a vehicle deployment, if it's a CTD deployment, whatever. That's one possible way to kind of handle it without introducing yet another system that the technicians need to interact with on top of everything else they're already having to interact with.
Yeah, and I'm just envisioning in my head, you have, you see in the data that it's collecting, the sensor gets knocked off, and you see that as an event where the data is 0, and then you see that the sensor's been swapped out under a different configuration. And so you'd be able to clearly identify what happened in all of those cases. Yeah, very interesting. So yes, that's a good potential addition point. Are there others that people can think of that they think would be useful from a visualization standpoint or a, you know, being able to interrogate tools that they're looking for or pain points that they're having? Yeah, Susanna.
Yeah, I would like to know if any one of you have experience with the sensor observation service, because we are looking at, for example, ISTSOS, just thinking on standardization. I don't know.
Any experience? I think it's is it the SOS sensor observation service? I don't have any experience with it. Anybody in the room? No, I don't think so, but it's probably something that we should look into and get a little bit more information on.
Our a couple of our station data managers, so for terrestrial stations, for Met information, do or have utilised SOS services. In fact, I think I might even had a poster at one of the previous polar data forums provided. So there's some in-house, but I haven't used it within the SDA project.
And see if they are, I think Tim's on leave tomorrow, but either tomorrow or Thursday, I can try and hook you up with someone and you can have a conversation. Okay, great.
We do have I've just looked, the web portal that they put up is still active, so even if you can't meet them, you can have a look at what they put together. And I do have access to the poster that they gave a couple of years ago.
Any other thoughts? All right, I feel like people are fading a little bit. The session was going to go until to 3 with a break until 3:20, but I actually probably don't mind giving people some network time. I think we've made a lot of good progress on the visualization side of things. So what we will do is we'll reconvene at 3:20, and then what we'll do is we'll discuss, I think I have on here, yes, the management of environmental data versus infrastructure data. So that'll be our last topic for that section. Also, while I'm here, I would say, do you also think about, are there things relating to polar vessels and polar vessel data that we haven't talked about yet? Things that, you know, you think that we do need to raise, or hopefully everybody's been satisfied by the discussion that we're having, but we'll talk about that topic. But if there are other things that people would like to raise, think about it during the break and then we'll discuss it. Does that sound like a deal? Reconvene at 3:20. We might not have the snacks immediately available, but go ahead and take a breather and then come back and we'll get refreshed with coffee or tea. Does that sound good? Okay.